Hello MIDI Comp. In this tutorial I will try to help you finish your Juno assignment. We missed the class last week because of my gig, so I want to make up for that lost time so you can go over this tutorial, and yeah, hopefully it will help you guys go deeper. We will be recreating this legendary synthesizer. You know, obviously there are different configurations, different buttons you can push. So some of them are easier to recreate than others. So for this assignment, I want to give you guys different options. So easy, normal, and expert. Just like in video games, you can choose your difficulty level. And please, by all means, if this is as far as you can go, I know it's early in the semester, and some of you don't have much experience with synthesizers or VCV, so it's totally fine if you just finish this little diagram here, as long as you understand. So I'd rather have you spend more time tweaking knobs and understanding what's going on, rather than going here and copying everything I do on the screen. You would just waste your time, and I swear I will not grade you based on how far you go. It's more about this is more about you using this assignment as exercise to understand fundamentals here. So hopefully it will be beginner friendly, especially this easy difficulty. For those of you who are really advanced, you can jump forward to normal if this is too easy. And later I hope you will learn something from these from the last part. All right, so yeah, let's jump in. Easy. All right, so let's start from easy difficulty. This will be beginner friendly, so if you're experienced, maybe you want to skip ahead and to next sections. This will be equivalent to our Juno having this waveform, square wave, with a little bit of PWM controlled from LFO, and filter being animated by the envelope, and the VCI will be in gate mode. So super basic sound here. So in VCV Rack, we always start, this is how I always start, from signal source, voltage controlled oscillator. So this is usually the module I want to bring in first. Right, so this is our VCO here, and we want to hear how it sounds. So that will be our audio interface. In this case, it's called Audio 8. So you want to set your audio interface in this menu here, sampling frequency, and this will be your left channel, right channel. So let's take this square wave. Perfect, it works. So we just made this connection for a moment between this and this directly. Now, because it's loud and we cannot control, we want to put an amplifier, right? This is a voltage controlled amplifier between these two modules. At first, it's just a convenience. So let's try that. Right now, I can shut down this oscillator, because remember, oscillators in synthesizers, they always keep playing something. It's just you need to mute them with some other module like VCA. So we have this, we have this, we have this. Now we need to put a filter in between, VCF. Right, so this filters sounds and cuts the upper harmonics. And here's the thing. There's also another module here, specified LFO and PWM. So what is that? Let's have a look at our waveforms. How actually this waveform looks like. I'm going to open this filter so you can see the square wave. Right, this is more or less how it looks like. And I will switch to digital so it's much cleaner to explain what's going on. Anyway, if we go straight from the oscillator, this is what you will see. And here's pulse width modulation. We're just changing the shape with this little knob here. And notice that the sound is actually much more interesting. So I would like to keep doing that. As soon as I stop, it's not fun. But if I keep doing this, I will get this really nice sound that is more alive. So we need to automate that motion somehow, because otherwise I would have to just move this knob all the time. So in order to do that, we bring another oscillator, but this time it's a low frequency oscillator. It's almost identical to VCO. It's just it specializes in low frequencies. You can even see, you know, it just goes very slowly. So that's all there is. And now I can connect it to the PWM input. And if I move this fader, this PWM CV, so this is CV amount. See? Now it's the same as if I was moving this knob over here. So once again, this is very similar to this. Right, so let's open the filter. Right, it's very, very similar. This is what this LFO is doing now to our oscillator. So that's what we have so far. We have this, we have this, we have this, we have this. Let's add MIDI keyboard to the mix. So that would be MIDI to CV. We're converting our MIDI input from controllers or even computer keyboard to something that the synthesizer can understand, which is voltage. So there are two main outputs. The most important are volt per octave and gate. This is basically pitch, and this is information that the note is on or off. So this goes into this input here. That's right. So this is our first connection, and now I can play it in real time. And the second one is gate, and this one helps us shut this sound down when I'm not playing. And I have a basically working synth right now. So remember these two, one is going here, another is going here. And in Juno, that would be equivalent. Remember, there's this switch gate here. So there are other modes here, but we're making this the simplest one. And so we have now MIDI keyboard, gate going to VCA, MIDI keyboard gate volt per octave pitch going to VCO, rectangle wave, controlled from LFO. PWM is being animated by LFO. And the only thing that is missing from this is our ADSR envelope. Why would we need that? Well, let's say I want the sound to be more like this. Right, like more plucky. I have to move filter constantly manually to do that. Again, synth design is all about being lazy, right? So we want to allow ourselves to be lazy. We want those little modules, these little robots to do it for us. So another module, just like LFO is helping us move this fader over here, I will use ADSR to move this knob over here. Obviously, we don't see this motion, but it's almost like you have to imagine that this is really what's happening. So here is our ADSR, and let's color code it so it's clean. So the way you hook it up is, again, gate. ADSR needs to know when to start creating this little automation, this little movement. It's like ADSR is like a little choreography of voltage going up with attack portion, then decay, then sustain level, and then it will take some time to release it all the way to 0. So it's like a 4-stage choreography that you need to trigger. You need to tell this ADSR when to start. So that's the gate. So notice that now the gate goes into two places. One is ADSR, another one is VCA. So it's very useful. And this ADSR now, when you press the key, you even see those lights showing which stage it is in. Now you take this output here and you put it into frequency input. And very important, you need to also turn this knob to the right. So this is frequency modulation amount. And you still don't hear anything because now this ADSR is moving this filter to the right when we're already maxed out. So I'm pulling back and now we can hear. I'm adding a little bit of resonance so we can hear this. It's more pronounced. And now it's all about tweaking. If you want it to make it more plucky, then and if you're new to this, this is the time where you should stop and really play with all the knobs and try to step by step get the really feel for this synthesizer. So let's have a look. We have pretty much everything from this diagram, and there's one more thing you can do. Since Juno 6, right, or 60 was polyphonic, it has 6 voices. You can play chords on the original one. And by the way, let's recreate that sound that we just did. So this was something like this. But resonance, filters low, envelope amount. Something like that. Obviously, I would have to spend more time to match them, but you can see you can pretty much do the same thing in VCV Rack. But there's one problem, which is in VCV Rack now everything is monophonic, and this is what it would be obviously happening in Eurorack. Everything is monophonic, but VCV Rack has this little option to switch magically everything to polyphony. So if you want to be authentic, do polyphony channels 6. And these cables are thick now. Right? And we have our Juno 6 in the most basic configuration, obviously without arpeggiator, and we didn't put chorus here, but I think this is a great start. And don't move past that if this is not like super simple. I'd rather have you stop and hand this assignment in this form. If you just spend more time fiddling with those knobs, understanding what they really do, and do this exercise a few times over until it's super simple. It should be really simple. You will have problems later on if we go to more complex designs. All right, so let's move to the next level. All right, so let's focus on normal difficulty. We will start from where we left off on the easy mode, and we will just add a few things. Everything that is supposed to be added is in red. So I will focus first on this connection from ADSR to VCA. Notice that till now, this VCA was controlled by simple gate, right? The gate goes, it goes here and it goes here. So the gate goes to envelope, but it also goes straight into VCA. The problem is that this gives you clicks, and it's actually on real Juno. If you listen very carefully, that gate is much softer there, but you can still hear it. However, on Juno, you also have an option here to switch into envelope mode. By the way, on the real Juno, this envelope 2 that wasn't here. It was only this switch going up and down. So this would be equivalent to envelope controlling VCA and filter at the same time. right? So there's a difference here. So this is what we want to do. And this is obviously very simple, because instead of going to VCA, we will take this output from the envelope. So now notice that the envelope is going, so the gate only goes to ADSR, and this ADSR is controlling both VCA and VCF. So this is done. Another little addition that is easy to do is this VCF, or it's actually, it's in real Juno, it was not a VCF, it was just high pass filter. So it's just a filter, but it's not voltage controlled. In our case, we just use VCF anyway. So this is what would happen on real Juno, and we want to have something similar. Simple filter. We will not control it, voltage control it from anywhere. The sound will just go in. So instead of going here, we'll go here, and instead, notice that in this is our main filter, low pass filter output. This is what we were using. In this case, we will just use high pass filter. So let's declutter a little bit. So this is what we're focusing right now, right? This, the VCO going to a high pass filter. Notice that there's no resonance. And finally, this is our main filter over here. Right, so this is good enough. And so we have this. Now, in here, we want to add saw wave and noise to our setup here. And this would be equivalent. So before we had only square wave. We want to add saw wave to the mix. And we also want to be able to add noise. Right, so this is what we are trying to do now in VCV, and in order to do that, we already have saw wave over here. If you see over here, there is sawtooth output. The problem is that we cannot just simply connect it here, because we cannot stick two audio jacks in. It's still trying to be Euro Rack, so you cannot simply put two cables into one input. So very easy, we have to mix them together before going there. So we're going over here and then over here, and we have these two waveform mixed, and you can go straight here. And here we go, it works. And we also mentioned noise. So for that, we will need another module, noise generator. And here we go. And you can mix, however, we can have a little bit more or less depending on your preference. So we have this. The only thing left is chorus. You can use any module in VCV Rack. These are usually third party. There's even one chorus that is replica of Juno chorus, right? So we are talking about this thing over here, right? So let's try that. This is actually the simplest thing to do. So yeah, I guess with this we have everything. Obviously, you can use other choruses as well. So yeah, we have now nice kind of Juno design in VCV Rack. I think it's not too complex yet. Yeah, so let's move now to the next. All right, and finally, the exciting stuff, the final diagram. Let's have a look what we are trying to achieve here. I added everything that is new compared to the previous difficulty in red, so you can have a look. This is pretty much the idea behind this diagram is that we want to explore the full configuration of the Juno. So first of all, we will look into our DCO, and we'll actually build it on our own with all 3 waveforms. So this will be equivalent to all of these 3. Yeah, right. So this will be our full DCO with noise. So pretty much heavy artillery here. And we also want to have PWM, and there's also vibrato. So a little bit of that, right? So this will be our LFO doing PWM and vibrato. What else do we have here? We also have keyboard tracking. So on the filter, this will be this knob. Notice that with keyboard tracking, the sound gets remains consistent across registers, but without, it will actually get brighter the lower you go, because this filter never moves. So keyboard tracking basically helps you move this filter frequency together with your notes. So this would be this connection over here. Finally, we will go back to this gate configuration on VCA that occasionally gives us a little bit of clicks because this gate is so abrupt. So we will soften it with slew limiter. And the exciting part is this legendary chorus sounds just amazing, but it's also extremely simple design. So we can recreate it very easily with 4 modules here. So we will go through that. So that would be, so, you know, the full configuration would be something like this. Envelope going to the filter. Yeah, pretty much everything, most of the possibilities here of the Juno, we're using all of these different subsections. Before we jump in, I want to mention DCO, because that might be confusing to many people. This is actually simple. Treat it more like any other VCO. It was more a bit of like a marketing tactic to highlight the fact that this DCO had very stable tuning thanks to added digital circuitry that was simply resetting oscillator core at very regular intervals. Previous VCOs usually have a little bit of problems depending on control voltage and temperature. It will never be perfectly in tune. So this DCO, this digital circuit, solved that problem. But remember, this is still an analog synthesizer, so it's just digitally controlled oscillator. Back in the day, you know, it was 1982. Everything digital was a sexy term. Now it's the opposite. Everything that it says analog, everyone wants to do that and wants to have that, and digital is what you throw in the trash. But times change. So let's have a look. So we will start building this whole thing from this homemade DCO. And it will be, we want to build it from simple singular core, because here's the thing. This DCO, this is one oscillator still with just 3 waveforms, and usually oscillators have either saw core or triangle core. Juno had sawtooth core, and these 2 other waveforms, this square waveform and sub oscillator or sub square, was derived from this core. So we will have a look how to emulate that in VCV. So let's grab our VCV plane. Yeah. So this will be our starting point, our saw waveform. I will switch it to digital for now because it will be easier to see everything. So how to get square from it? Obviously, it's very, what I'm trying to do right now will be very impractical because we could just do that, but for educational purposes and for fun of exploration, we will do it a hard way. And here's the thing: if you use a comparator right on that saw, so let's try that. It can be any comparator. You will get a square wave, right? Comparator simply says that if the voltage is above certain level, in this case 0, you will go into high voltage. And a little bit of housekeeping. We can now scale it. Now maybe, yeah, this module is good. So what we notice that this square right now sits in positive voltage only. So I will just for making it look pretty and sound pretty, I will simply position it properly. So I will amplify it and then offset. So now we have nice oscillator with 2 waveforms, and so this would be that part, right? Comparator and saw wave. Now notice that if I move this threshold, I get PWM, right? So simple. So all I need to do right now is animate it, right, with triangle wave, and boom, right, and I have a nice PWM, homemade PWM, and let's actually start listening to what we're doing. So let's see, audio 8, set your audio interface, sampling frequency. Okay, let's see. And maybe I'll put VCA so I can shut it if I want. Right? This is our sound right now. However, I mentioned that in this original Juno, we also have LFO that could control DCO, which gives us vibrato, right? So the same LFO I will send right now. Let's color code it so we know what we are supposed to focus on. So the same LFO will also go into FM input of our oscillator. Right? Now it's vibrato with PWM. Obviously we want to have a little bit of that. So that would cover, in our diagram, that would cover our LFO going into FM input, so vibrato, and giving us PWM. So we have comparator, we have rectangle wave saw. Now the only thing missing from this side is the sub, and that can be derived very easily by another module, which is called flip-flop. These are actually equivalents of electronic components. So now I'll take the same, okay, let's color code it. I will take the same core, oscillator core, right? We still want to have this saw core, and I will send it. I will compare it here with the result. So what flip-flop does is whenever voltage goes above 0, it will go into, it will flips. It will go up, and then next cycle, it will flips down, and that's it, right? It flips and flops. It's not a rocket science. So just like before, I will copy this offset just to look pretty, right? And I have a nice sub. So I have 3 waveforms, and let's organize it a little bit so we can hear how it works. So with 3 waveforms, I obviously have to mix them together. So the first one is from our oscillator core, right? So let's mark it. The second comes from our comparator. That will be rectangle with PWM and with offset, right? So this is where it's coming from. And the third one comes from our flip-flop, also with scaling and offset. Ta-da! And let's hear it. Right, obviously it will be aliasing because these modules are not designed necessarily to do that job. But yeah, massive, aggressive sound. And obviously we still need one extra module here, which is noise, right? This was already in our previous versions. So let's do noise generator. And a little tip, if you guys want to build this but also have it polyphonic, you might want to replace these modules with polyphonic modules, because everything in your chain eventually will have to be polyphonic. But if this is good enough now for mono, just heads up. Yeah. So you can adjust the level of your sub, of your noise. So we now covered our sound source section. So everything here, we have it nicely organized here. After the mixer, we have all these nicely mixed together. So let's now go and quickly recreate these two modules here, filters, right? So high pass filter, we had it in previous version, in previous difficulty. So let's just put that simple VCF on the way. Let's declutter a little bit. So this will go into VCF, but high pass filter. Then after high pass filter, we're going to low pass, just like before. Let's color code so we know that these are important. Right, so we are covering that section right now. So this will be our main filter, this one. Low pass, so we can actually use resonance on this one. And it goes to VCA just like before. Right? So this is basically this stuff here. So this is, we covered that before. Now, what I want to do is show you keyboard tracking. For that, obviously, we need to also add MIDI keyboard to the chain. So let's add MIDI CV as before. Configure your keyboard, and remember, maybe let's unmark these cables. So because now it's getting a little bit busy, so I want you guys to be able to focus on what's important. So as always, we want to have this volt per octave to our oscillator core, to our main oscillator, right? And it's very elegant. This is the only thing we need right now, because we have only one oscillator core. So this will allow us to to play these sounds. And now we also need a gate going to our VCA here. So this is what we had before. So MIDI keyboard going into oscillator and gate going into VCA. In a bit, I will show you how to soften that. But what I want to focus right now is on the filter, because we need to have two things going into this filter. ADSR, so let's actually put that ADSR, we had it before. Let's put this ADSR into our chain, and it's getting really busy. Maybe in a bit I will start breaking into two rows. Let's see, maybe it will be cleaner this way. Yeah, maybe it will be easier to see. So this time this gate will go over here, right? And ADSR is going to our filter. As before, we have to open it. Usually I turn this filter down, and then obviously we need to play with a little bit. Oh, sorry, I went into wrong filter. Obviously, this is our main filter, right? So this is our high pass filter. Yeah. So this is now. So now we have nice filter. And here's what we also need to do, and this is the whole point. So we have this ADSR right now connected, but we also want to connect our pitch information into the filter. So what we want to do is take this volt per octave and put it into our filter. Notice that we can't because it's something else is already here, right? We cannot just put two cables into one input. So what we need to do is fairly simple. We need to mix them together. I will actually use Unity Mixer just for variety, so it doesn't have any knobs. So the way it works is that previous signal from here, this ADSR, you can just put it here, right? And then the second one would be, so this goes here, right? And we need to start decluttering those colors. So this is what we're focusing right now. Gate going into ADSR to the mixer, and then from the mixer it goes to VCF. And this way we can also mix this control signal with keyboard tracking, right? So that would be volt per octave going here as well, right? And this way, the sound is consistent. Notice what will happen if I disconnect it. Right, the higher sounds are slightly more. They are darker in a way. Right, so sorry, this way. So that's the whole idea behind the setup here. All right, so we covered this part now. So we have everything from here to here. We're mixing it, VCF. This is actually very simple. That click that sometimes can occur. So let's simulate. Right. Occasionally we can get this click because it's this gate is just too abrupt. So what you want to do is, okay, let's again decolor everything to black and white so we can focus on what is the problem. This is the problem, right? This goes from gate to VCA and it's so sudden that we get clicks. So all we need to do is instead we need to put a slew limiter on the way. You could actually put envelope on the way, but slew limiter will be simple. And notice what happens now. Right? We are softening this gate. Obviously, this is not how Juno works, so it would be very, very subtle softening. Nice. So we solved it. You can actually use a low-pass filter instead of slew as well. It's a nice way, another way to induce slew. But this is good enough. So we covered this part. We have everything, guys. Hey, we're almost there, and now is the fun part. If you are with me still, building this iconic chorus. That's I think it's fun part because you can actually you can do it fairly well. I will just show you basic stuff. I won't tweak it to perfection, but the idea is that the signal goes into two delays, left and right. And the times of those delays are being animated by LFO. And when one goes up, another goes down. So let's have two delays, right? 1, 2. So again, decolor. We will focus right now on this path over here. From our VCA, this is where the final signal of our synthesizer is coming out. And now we are just, we care only about the final chorus effect. Right, they're going to two delays. You don't want feedback. You want just a very short time, maybe 0.02. And they are going left and right. Maybe let's just, so we know what's going on. Now, still nothing interesting is happening. But notice that as soon as I move this time, right? So when I'm moving this tiny little bit, we get this chorus effect. So what I need to do is apply LFO. to both of them. The problem is if I go straight like this, then obviously it's too dramatic, too drastic, so it won't work as chorus. But I can scale it with this 8-verter. Right, so let's maybe focus on just the top one. So LFO going, it's being scaled down to like, you know, a few percent. Maybe it's already too much and very slow. Maybe bipolar. And it also, you can use another row that they are normal. So you get output on the other, but this time we're going lower, like minus few percent. And then obviously you can mix. Yeah, you have, you know, we would have to tweak those times. Yeah, I would have to see exact LFO rate, but that chorus in Juno, this button 1, 2, that basically what sets up different times of LFO. So yeah, here we go. We have, I think we have everything. Yeah. So we have that. And hey guys, if you're still with me here, then it means that you really like either synthesizers or VCV. So welcome to the club of addicts. And yeah, let me know if you have any questions. Hopefully I will be able to meet you soon next week, or actually this week. So so go over this tutorial and let me know if something is still unclear. All right, thanks for listening and see you again. Bye-bye.